Very good morning to everyone. My name is Yap Yan Xiang. Today I will be presenting anomaly detection based on tiny machine learning, a review. Table of content. These are the titles that will be covered in the slides. First is the introduction, followed by supervised learning, unsupervised learning, semi-supervised learning, tiny ML, tiny machine learning, model optimization, and conclusions. So for the introduction, first is the highlight, then lead to motivations. What is Industry 4.0? Industry Revolution 4.0 describe the growing trend towards automation and data exchange in technology and processes within the manufacturing industry. Currently, we are in Industry Revolution 4.0 and moving towards Industry Revolution 5.0. Industry 5.0 refers to people working alongside robots and smart machines. So the problem statement is occurrence of system failure. Reliability is the main attribute for safe operation in any modern technology system. The aim is to shield the system beyond the uncertainties of its accidental situation. So why tiny machine learning is important? It is an innovative approach to reduce breakdown of equipment. Machine learning can be categorized into three different machine learning, which are supervised learning, semi-supervised learning, and unsupervised learning. For supervised learning, learning process is done under scene label data. For semi-supervised learning process is done with both labeled and unlabeled data. And finally, unsupervised learning process is done with unlabeled data and the response variables are not available. PHM Prognostic Health Management aims to improve the reliability, enhance performance ability, reduce the maintenance costs, and predict future values of phenomena. This slide talks about supervised learning. This is the ingredient of machine learning. So this equation for fx is the information that the feature vector x provides about the label y. In general, machine learning is the estimation of functions that can map the input to obtain the output. There are two subcategories of supervised learning, which are classification and regression. Classification predict a continuous value output. Regression predict a discrete value output. Example for classification are linear regression, support vector regression, and for regression, the examples are k-nearest neighbor, random forest, and support vector machine. Furthermore, this slide talks about semi-supervised learning. Semi-supervised learning uses both labeled and unlabeled data for training. Graph-based model (GBM) is one of the famous semi-supervised learning approach. It is a graph constructed with nodes and edges. So this is an example of a graph-based model GBM. Nodes are specified with unlabeled and labeled samples. Edges are the linking between nodes, which determine the similarities among the labeled and unlabeled samples. This slide talks about unsupervised learning. Unsupervised learning is not focusing on predicting the output since there is no output variable. It is trained via unlabeled data and aims to explore the feature space and find patterns in the data set. It can be sub-categorized into clustering and anomaly detection. Clustering is used to discover the data analysis and find the patterns in the data. Example is k-means clustering in image segmentation. For anomaly detection, it identifies the patterns that do not follow the expected behavior. Examples are self-organizing maps, SOM, k-mean. Applications such as cyber intrusion detection are often using this unsupervised learning approach. Tiny machine learning. is the deployment or integration of machine learning in microcontroller units (MCUs). MCUs are embedded devices. It aims to bring machine learning inference to ultra-low power devices such as under 1 milliwatt. Since MCUs have limited memory space and onboard horsepower, therefore small model is needed to fit the tight constraint of MCUs. TensorFlow-like Micro is a tiny machine learning framework that developed by Google. It enables implementation of machine learning to MCUs. There will be several slides mentioning about model optimization. Model optimization is to reduce the size of the model. One of the techniques is pruning. Pruning aims to reduce the number of connections in the neural network model, as we can see in this diagram. Han had proposed pruning the redundant connections. Ridzuan is wave pruning that improve network. Who prune unimportant zero activations neurons, and Days Fisher pruning that obtain runtime efficient. Quantization. Quantization is a process where the network size is further reduced by reducing the number of bits needed to represent each wave. Jacob had introduced the quantization scheme. Quantization scheme implemented using integer-only arithmetic, applied quantized training on ResNets and inception v3 on ImageNet datasets. The integer-only quantization outperformed FGQ. Fine-grained quantization and the mobile nets have become more computationally efficient. This slide talks about knowledge distillation. Knowledge distillation is an alternative way to transfer knowledge from large neural network to small neural network. Firstly, train the large neural network and obtain the output. Pass the output from the large neural network to small neural network, and the output is backpropagated to the smaller neural network, and now the smaller neural network can replicate the behavior of large neural network. So on MNIST distillation, it works remarkably well. However, for large neural network, long time training is required. Singular value decomposition (SVD) decomposes a weight matrix W into three matrices. The sum of the three matrices is smaller than the original matrices. This will reduce the dimension of matrices. As the matrix area is smaller, the size of storage is smaller. Clemma had shown that SVD can be used to compute reliably a number of basic geometric objects of linear algebra. Xue applied SVD to weight matrix in DNN. Cai fast training methodology for learning DNN, and Lane had introduced a DeepX software accelerator. For binarization is a one-bit quantization where data only have two possible values, either -1 or +1. This equation is an example of quantization. It can reduce the memory size and improve power efficiency. Kobayashi is the first person to introduce binarized neural network (BNN). Banjo weights can be maintained. Krishnamurti, better performance of a model can be achieved, and Alizadeh proposed an approach that operates well in terms of accuracy and converges even faster. In conclusion, TinyML is an innovative approach for anomaly detections. There are three different machine learning algorithms, which are supervised, semi-supervised, and unsupervised learning algorithms. There are several types of model optimization with the aim to reduce the size of model. Industry Revolution 5.0 emphasizes on cooperation between humans and machines. Using TinyML, the human safety can be ensured. These are the references. Thank you for listening.